So my name is Faris. I'm a co-founder of Tercen, and I've been working in the with OR for 20 years. So I've been in the biotech world using OR, especially the bioconductor packages. So I love OR, and thanks very much for inviting me here for the 15 minutes and organizing this. I think OR should be promoted, and it's good to see these initiatives. So I've been dealing for the last 20 years with two types of people: coders and non-coders. So of course, I'm a coder myself, so I relate to coders, but the biologists that I was working with were non-coders. And the biologists, these are usually sometimes medical doctors, oncologists, clinicians. So there's a lot of non-coders compared to coders. Some of the non-coders end up trying to learn coding, which happens to be successful maybe 10%, 20% of the time. I've tried to convert many non-coders to be a coder, and that has always ended up kind of partially successful, but overall 80% of the people wouldn't have finished my workshop for coding. So I knew something needs to be done between these two communities, and the objective of my presentation is to show you how you can basically get non-coders to be using more OR packages and more OR algorithms. So that's the objective. And I want to show how we liberate basically the coder as well, and how we empower the non-coder. So I'll start. So when a coder produces a OR package, it's already quite a lot of work to make the OR package, but it's pretty cool and it's pretty useful. And now the question is, how do you bring this OR package to the non-coding world? Sometimes the package is not meant for non-coders and it's only meant for coders, so that's okay, but majority of the domain experts are non-coders. So you end up with package management issues, and I think there's a talk talking about that with ORENV. You end up with data management issues for like data wrangling, making sure that the data can be uploaded and manipulated, stored. You deal with deployment issues, maintenance issues, and how to maintain the OR package, but also maintain the communication with the non-coder and how to use it, how to train the non-coder, how to support the non-coder, how to supervise the non-coder, and the workshops that you would do to try and get the non-coder to use your OR package. So this is a typical scenario. I've gone through this myself, and it's quite making the package is fun. And the last 20%, which takes 80% of your work or time, is actually trying to get it being used and available to be quickly used by non-coders. So in the end, liberation is all about trying to get the coder just to focus on making packages and innovating and supervising methodologies and education, and with zero deployment. So you want the coder to basically code the kernel of the package, and you want the non-coder wants to be able to get control of the data, add meta information. I noticed this a lot with biology. They always want to add meta annotation. So the OR package is one layer, but they want to put extra layers on top. They want to visualize more. They want to explore, especially with exploratory data analysis, and they want to handle large sizes. I say they want to be empowered. So maybe people are not aware, but the machines in the labs are starting to produce quite a lot of data. Before, the run used to taking the design of the experiment would take a while, but the run would take the most of the time, and the analysis would be some part afterwards. But now in the current situation, and it's been a revolution in the last 20 years, the designing is a little bit more complex. The running happens over 1 or 2 days, or sometimes an hour. And you spend more time in analysis. So the domain experts, like the biologists, end up doing more analysis than they would normally have done. And to make things a little bit worse is that usually there's only one coder in the lab, and a lot of biologists who don't code. And this ratio is pretty. I've seen ratios of 1 to 14. I've actually been in one department, it was 1 to 30. So there is a bottleneck here, and there is a problem, and we need to get harmony between these two. because at the moment it's not harmonious. Well, sometimes it is harmonious and it does work very well, and that's fantastic. But in a lot of cases, there's just not enough coders. So we want, and that's what I'm going to show you now. I started Tercen to solve this problem. A lot of people are using, especially the non-coders, they're using Prism and Excel, and the coders are using SAS, Python, and Bioconductor. In the y-axis here, I have this coding skills that are necessary. On the x-axis, I have whether it's small data or large data. And you can see Prism and Excel are up here on the top left. That's because they have that you don't need so much coding and you can do quite a lot. You can do quite a lot down here with bigger data, with Python and SAS and Bioconductor. And I try to hit this spot here and capitalize on the OR community because I'll show you this, how I did this. But I basically wanted to put a layer on top of OR that non-coders could use. Compared to Tableau and Spotfire, which would be my closest equivalent, they're not as flexible as Tercen, and you'll see now as I do the demo. So I want to show some use cases where I have managed to change things. One thing is the large Excel. This is where the bioinformatician or the coder has produced, using the pipeline, has produced a large Excel. And I'm going to show you how that was manipulated by the non-coder. I'm going to show you about a Shiny app where I show you how a coder made a Shiny app and then deployed it, and then the non-coder could use it in a much more flexible way. And I'm going to show you meta annotation, how to add meta annotation. For example, while you're wanting to use the Shiny app, the biologist may want to add some meta annotation. So I'm going to show you the files that I'm going to deal with. So this is my desktop. Basically, I show you what a bioinformatician supplies a non-coder. So this is a typical type of data from the bioinformatics world. You basically have a column of genes, and you have all these columns here called basically samples. So what you basically, this Excel is given by email or sent by email by the bioinformatician to the actual non-coder. And this is what I suggest they do. They use, I'm clicking now to go to Tercen. So this is the Tercen platform. You can see here, it looks very much like GitHub. I took a lot of the ideas, or inspired by GitHub, and I'm trying to make it GitHub for biologists, basically. And here you can create a new project. For example, I call this the online demo project. And when you create a project, you can start uploading your data. So you click on new data, you select the data, which is the Excel that I just showed you, for example. Let me just minimize this. Yes. So you select the Y data here, and you open it. You say, OK. You say next. Here you see your Excel that you're going to upload, but you have an advanced tab here where you're allowed to do this gathering, which is something that in OR you do quite a lot, but non-coders don't do it. And here they can start gathering. What am I gathering here? I'm basically gathering all the columns except the gene ID that I showed you. And these columns represent the samples. So I'll give them a sample name, and I'll give the values measurement name. And so now I have uploaded the data, and I've managed to do a gathering. Then you can start a new workflow by clicking here and say analysis. So this is what the non-coder would do with the data that was being produced by the coder. And they open up and you get a canvas, a completely white canvas. And you can add onto the canvas and start adding data, which is called a table, which is the table I just uploaded. So you can see here, I have added the table. Now I can add a data step afterwards, and it automatically opens up this data step. Here is where most of the concepts of Tercen and why I call it a kind of GUI layer to OR. Because you can, here you see, these are the columns that I have now, the measurement and the sample. This is after the gather step when you import it. And I can put measurement anywhere. I can put it as a filter, as a color, as an error bar, as a y-axis or a row, or an x-axis or a column. Here I'm going to put it as a y-axis. and I can take sample and I can put it up as a in all of those green areas that light up here, but I'll put it as a column concept because that's the way the Excel was as well. And I'll put the gene ID as a row concept because that was also the kind of projection that the genomics guys, non-coders or the domain people from that domain do. And you see, it's like the Excel. I've just basically visualized the Excel. And with the measurement, you can now color with the actual heat map. And in this heat map here, you see, so you can start making projections. And there are a couple of projections you can make. I can go back to this and I can rename the data step and say this is a heat map projection of this file, this large file. And I can duplicate it and say, well, I'm going to do some computation on it. I'm going to do a simple mean as an illustrative step. And here I'm going to remove the sample. I'm going to stop the coloring and I'm going to go into point mode. And in point mode here, and because I removed the sample factor, which was in my original Excel after the gather step, it's got rid of the grouping. It's like removing a group by, and now you have a group by just by genes. When I say group by, for people who code, they know what I mean from the tidyverse vocabulary. So now you have a gene, basically all the values for the genes for all the samples here. And now I can add a mean step, for example. Here's a mean step, and the mean step is an OR operator. And I can click here to show you what it does, but I'll first run it. Well, I'll actually click here and I'll show it to you immediately. It goes to GitHub. All our operators are on GitHub. And basically, you see here is the code. This is the mean operator for us. It's basically a group by, and then you call the mean operator and you save it. And that's what is being executed here. When I do this mean, I run it. It causes the mean to execute. And I add a step afterwards, a data step. And this is the beauty of Tercen, is that you can, once you've calculated something like the mean, you still have the original factors, but now you have this extra thing here on the left called the mean, and it's made a projection with the mean. So you can, for example, do a heat map on the mean. For example, you just calculated the mean. This is the mean. You can take the mean and you can use it as a factor to change the view. Let's say I want to order by the mean. So I'm ordering the mean of every gene, for example, across all samples, and you can see it orders it perfectly. And this allows you to basically keep adding a workflow and keep adding steps and operators. But let's say, for example, that in my heat map, or let's say you have a Shiny app, and I'm going to add a Shiny operator at the moment. Let's say the bioinformatician has made a Shiny operator. I'm going to take one now. I'll look at on our GitHub, look for the Shiny one. I'll take the Shiny heat map, which is down here, Shiny heat map. So I'm going to install this operator from GitHub into Tercen, and I look at this Shiny operator, and I look at the tags. It's 0116. So I go back to the Y or team area. I go to the libraries. I add from Git the actual. I think it's 0.16. I said. This is not important. So I've installed it, the Shiny heat map, and I can go back to my protocol that I was working on here, and I can add to the heat map we made. I can personalize, and I can click here and add the Shiny heat map. This is and immediately you see on the left here a tab appearing. I click on the tab, and you can see that the Shiny is actually running on the projection. So this projection here is the data, and here is what the Shiny is actually executing. It's using the data from the projection. So the beauty of this is that for a non-programmer, they can go back here and they can remove, for example, genes and samples. if they wanted to. They can like only keep this one, keep only a subsection of the data. This is a filtering step, like we call it in the tidyverse. So the non-coder can do filtering, can do ordering, can do basically everything a programmer can do. Not everything, but most things for manipulating the data. And then the shiny here will only get the subselection that has been selected by the non-programmer. This means that the programmer, the OR programmer, is liberated from all the data management issues that can be associated with making a shiny. So we basically have a cloud version that you just saw. You can download the dev version in Studio. It's called Tercen Studio. It's an OR Studio with a Tercen OR package. We have an enterprise as well. And I've gone through all these basically cases. I didn't show you the metadata. I'm a bit limited for time, but you can also do a join step like I showed you, or like I showed how you added a data step. There's a thing called a join step. And we think that Tercen, hopefully now I'm convinced you that you can liberate yourself from a lot of the details. When you write OR code, you will deploy it to Tercen, and the user will be able to, the non-coder will be able to do quite a lot with your OR package or your shiny. I'm looking for OR coders and use cases, so please contact me by Slack about if you want to work with me or work on a use case. I'm looking for OR coders. Excuse me for the lousy photoshopping here. That's supposed to be me. And it's free, so you can go to Tercen and sign up. And you can look at the GitHub that we have. You can see all the code and how OR operators are working. So thanks very much. This is Faris. You can ask questions on Slack or contact me by email here.